everybody. My name's Perry Coleman and I work for a small consulting company called Delta Environmental Consulting. Some of you may have met me before as we wandered through the Saltmarshes at Arno Bay. Many of you will have heard me talking about saltmarshes and how they are the nursery for our fisheries, the larder for our migratory shorebirds that travel from the northern hemisphere, and home of thousands of as yet unnamed beneficial predatory insects that keep our horticulture industry viable. You may have heard me talking about the amazing ability salt marshes have to keep pace with rising sea levels and how they prevent coastal erosion. But wait, there's more. Salt marshes are also carbon sinks, and we call the kind of carbon that they sequester blue carbon. Why do we call it blue carbon? Because this is carbon that is buried into a salty environment. Salty environments, like seawater and salt lakes, mean that the buried carbon cannot decompose to release greenhouse gases. We say that salt impedes methagenesis, so carbon that's buried in salt marshes, mangroves and seagrass beds is permanently captured. But is blue carbon a significant carbon sink? Yes, blue carbon is an important carbon sink. It's important on a global scale. One example of this is the Azolla Event of 49 million years ago, and it occurred at a time in the Eocene when carbon dioxide in the atmosphere was so high that big mammals could not exist because warm-blooded animals have to be able to lose heat, and it was too hot for large mammals to survive. Only dwarf forms existed, and only in the Arctic areas and the Antarctic areas. In these areas, fresh water floated on top of the salty Arctic seas, and a massive bloom of Azolla water fern occurred. That's the water fern that you still see in freshwater ponds today. As the plants died, they fell through the water into the saline water below, where their carbon was captured. The drawdown of atmospheric carbon stocks was significant, cooling the planet sufficiently that large mammals could evolve. There was about 800,000 years of Azolla bloom episodes, and they occurred over a 4 million kilometre basin of water. And even by very conservative estimates, more than enough carbon was sequestered by plant burial to account for the observed 80% drop in carbon dioxide by this one phenomenon alone. So we know that blue carbon can make a massive change to both carbon dioxide in the air and the cooling of the planet. But where are our modern carbon sinks? Modern carbon is sunk into seagrass meadows, mangroves and salt marshes. As you can see, these three main blue carbon sinks currently account for much larger amounts of carbon sequestration per square metre per year than forests do. When people look at the low-growing salt marshes, they often say, but where is the carbon? There aren't any trees with all the carbon locked up into the wood, so where is it? Carbon in salt marshes is captured by a thin film of blue-green algae with diatoms that live on top of them on the mud surface. This living film is slimy and a bit sticky. The slime is made of long-chain polysaccharides. Polysaccharides are sugars, and they're made up of carbon, hydrogen and oxygen. And the organisms produce this slime to prevent themselves from drying out or getting burnt by too much salt. When the tide comes in, the small sedimentary particles in the incoming tidal waters get stuck in the slime, and this buries the carbon in the slime, The diatoms and the blue-green algae migrate up to the surface through the sediment. They make new slime and are ready for the new day. And this is how salt marshes both grow their elevation and how they bury so much carbon. But not all the carbon gets buried. A food source is a food source after all. So some of you will have heard me talk how this very same slime drives the food web that supports the fisheries of the Spencer Gulf. So we'll just take a quick look at that before we actually finish this talk. The little salt marsh mud crabs, Heliograspis haswellianus, scurry around eating all the slime they can. Then, at the higher tides of the month, when the salt marsh surface is inundated, these crabs release their zooae synchronously from the second night of flooding in countless numbers. Studies in New South Wales with fish that enter the flooded salt marsh find that the stomach contents of the little fish were 12% heavier than the same species caught in the creeks and channels before the flooding of the salt marsh. Also, they are 12% heavier than the same species caught in areas where there was no salt marsh. And all of that extra food was crab zooae. That brings us to the end of today's presentation. And usually at this point I ask if you have any questions. Common questions that I get asked are, where is there a salt marsh that I could visit that's near me? And what should I look out for when I visit the salt marshes? And finally, how can I look after salt marshes? Salt marshes occur quite extensively down the eastern side of the Eyre Peninsula. You have quite large salt marshes in Franklin Harbour near your school. Tumby Bay and Arno Bay both have extensive salt marshes. And south of Whyalla, the Cowled's Landing Sanctuary Zone has some beautiful walks in the salt marshes there. Some of the things that you can look out for when you visit salt marshes are the holes of those little mud crabs. Which parts of the marsh do you find that they occur most in? And many of our salt marshes are struggling with off-road vehicle use and dumping. So these are two things that you could avoid to make sure that the salt marshes near you stay healthy. If you have any other questions, just hop on the socials that are listed below and I'll see if I can answer them for you.